All right, good afternoon, everybody. Let us get started. As you know, this Friday is the comprehensive test. I posted the time on Teams as well as in the WhatsApp group. I hope you have it. I think it's 5 o'clock on Friday. I can't really remember, but the time is there. You can check. Please make sure you're there on time. Have everything you need. Bring your student card, calculator, yeah, just all that stuff. So today what I want us to do, since we are done with the course outline, is to just go over some past papers. I think we'll only do one, and then on Wednesday we can do another one or continue from where we leave this one off. Now, those of you who came for the face-to-face tutorial, we did the 2016 paper. This was a paper November 2017. It was a 3-hour exam and 100 marks. So the test you're going to write is 90 minutes, so it won't probably be as long as this one, but the structure is pretty much the same. Okay, so all the papers I've seen, they all start with the multiple choice section, and then we have questions in different sections. Okay, so let's just quickly get into it. Now with the multiple choice questions, the first one, it says write down the letter corresponding to the best answer for each question. 1.1, when the population is divided into mutually exclusive sets, and then a simple random sample is drawn from each set, this is called. Okay, now this is not simple random, because simple random you don't divide into groups. The only two types of sampling that involve groups are either stratified and or cluster. Now, systematic is the one where you pick every 10th person, every 10th car, or every nth something. So the ones that involve groups, stratified or cluster. Now, what we know about cluster is that you pick a cluster. So you have your different clusters, and then you take a simple random of the clusters. But stratified is the one where you take members of the strata. Okay, so our answer over here, okay, it won't let me highlight. Okay, so the answer over there is B. See, comment. Okay. And then 1.2, a market research firm divides the population of a state into geographical areas, and then randomly selects some of the areas and takes a simple random sample of each selected area. Now this one is an example of a cluster random sample. Okay, so the answer is A. So remember that cluster and stratified. With cluster, you are picking some of the clusters. With stratified, you are picking members of each strata. So 1.2 is A. Then 1.3, the Laspeyres index formula uses the weight of the base year, because the Laspeyres means we want to find out how much we were using in the base year, how much would that cost us now, divided by how much we were using in the base year and how much it cost in the base year. So it's Q naught P1 over Q naught P1. So the weights That is your quantities. Those are the base period, base year. 1.4. A manufacturer of contact lenses is studying the curvature of the lenses it sells. In particular, the last 500 lenses sold had an average curvature of 0.5. The population is, okay, because this manufacturer is studying the lenses that they sell, then the population is all the lenses that are sold by this manufacturer. This 500 over here, this would be the sample. This 0.5, this would be a statistics. It's a statistic. It is an average of the sample. Then the lenses sold today, that could be a sample. Maybe you took the average of the sample that were sold today. Okay, so 1.4, the answer is D. 1.5, a political scientist is studying voters in California. It is appropriate for him to use a mean to describe which of the following? Okay, now the mean describes continuous data, not data like political affiliation, because you would have, I know in the USA, it's Republican, Democrat. What does an average of that mean? So that wouldn't be appropriate here. Sex, male or female, what does an average mean? And the county of residence, whatever place in California, you can't take an average of that. So the appropriate one that a mean could describe is the age, because you can calculate an average age. And then 1.6, a researcher is studying students in college in California. She takes a sample of 400 students from 10 colleges. The average age of all college students in California is, now this is the average age of all college students, and she is studying college students in California. So this average age is a parameter because it is derived from the population. So 1.6, the answer is B. It is a parameter because this is the average age of all the college students, unlike if she had taken the average age of these 400 over here. So if she knew the average age of these 400, that would be a statistic. But because it's the average of all of the college students in California, it is a parameter. Then 1.7, the standard deviation of a normal population is 10. We take a sample of 25 items from this population and compute a 95% confidence interval. In order to compute the confidence interval, we use okay. Okay, we take a sample of, okay, here we, but in order to compute the confidence interval. So here we have a standard normal, the standard deviation is 10. So we know the standard deviation. So remember what or how we decide whether we use the Z or the T. We first ask ourselves, do we know what sigma is? That means the standard deviation of the population. If we know what the standard deviation of the population is, then we use the Z. So here we know the standard deviation of the population. So it has to be a Z table that will be used. So it's not going to be A and it's not going to be B. Then we take a sample of 25. Oh, okay. So here it says there's these two options, the Z table because the population standard deviation is known, or the Z table because the sample size is small. Yes, the sample size is small, but because the standard deviation is known, then we will use the Z table. So C is the correct answer. I hope you guys are following. It feels like I'm talking to myself.
We're following that. Thank you.
Okay. All right, then 1.8, if in a random sample of 400 items, 88 are found to be defective. If the null hypothesis is that 20% of the items in the population are defective, what is the value of the test statistic? So here we have to work out the test statistic. Let me just show you. Okay, so to work out the test statistic, we use the formula Z is equal to P minus pi over the square root pi 1 minus pi over n. So that is our Z statistic. Then we substitute everything we are told. We're told that 88 of the, let me see, 88 of the items, it just says items are defective. So P is 88 over 400. And our pi over here, this is the value we get from the null hypothesis. So you look at the null hypothesis, it says 20%. So that means that pi is equal to 0.2. So pi is equal to 0.2. Okay, so we'll calculate this. Z is equal to 88 over 400 minus 0.2 square root 0.2, 1 minus 0.2 divided by the square root of divided by 400. Okay, this you can just type in on your calculator, and I got 1 when I did it. Okay, this one. And then we look at our options. Okay, there is the answer that we got. So the Z statistic is in fact equal to 1. Then 1.9, we have to, we are told that a 92% confidence interval for population proportion is 32.4% to 47.6%. The value of a sample proportion is, so here what they're asking for is what is P equal to, because you know our confidence interval, we always say P plus or minus the Z alpha over 2, and then square root P 1 minus P over n. So the question is, what is this P over here equal to? Okay, now this one, let me just see, we are told that, let me just go back. We are told that the confidence interval is from 32.4% to 47.6%. Okay, so this is how we construct the confidence interval, and we know that our P is always in the center. You subtract a certain amount from the P, you will get this value, and then you add a certain amount to the P, and then you will get this value. So this P over here is right in the middle of these two numbers. So to get the value of P, all you need to do is add them together and divide by 2. So you don't need to work out this and then come up with some complicated equation. You just need to know that the sample proportion is exactly in the middle of the endpoints of your interval. So to work this out, I will add these two percentages and then divide by 2. Say 32. Let's do that. Okay, so you'll say 32.4 plus 47.6. You add these two together, 32.4 plus 47.6. This gives us 80. And then you say 80 divided by 2. This is equal to 40. Okay, and sometimes just looking at the options that you have tell you, okay, this is probably the answer. Now, looking at this, it cannot be this because that's the end point. We know that our proportion must be in the middle. This is also the end point, and this one over here is outside the interval, and we know that our proportion is always in the middle, and this is in the middle, and it is the one that we worked out just now. So the answer is equal to 40. Okay, then 1.10. In a simple random survey of 89 teachers of high school AP statistics, 73 said that it was the most satisfying, most enjoyable course they had ever taught. Establish a 98% confidence interval estimate for the proportion of all high school AP statistic teachers who feel this way. Okay, so we know that our confidence interval, this is 1 to 10, interval constructed by saying P plus or minus Z of alpha over 2 square root of P 1 minus P over N. Okay, so you guys just quickly try it. I'll be back in 2 minutes. Okay, let's go over it. I hope you have the right answer. So we are supposed to construct 98% confidence interval. So this means that alpha is to 0.4. Okay, so we're looking for Z of 0.01. So this value over here we read from our table. So the Z table is provided for you. What you do is you look for 0.01 over here, and then that will be our Z value. So looking at this 0.01 is okay, so it's between these two. I would say it is closer to this one over here, and the value is negative 2.33. So our Z value here is going to be plus or minus 2.33. Then we know what our P is. That is it 89 teachers? Sorry, 73 out of 89. Yeah, so we have 73 out of 89. That is our P. So P is 79 out of 73 out of 89. Okay, so now we can construct our confidence interval. So P, this is 73 over 89 plus or minus 2.33. The square root 73 over 89 multiplied by 1 minus 73 over 89. This is all divided by n, which is equal to 89. So this you do on your calculator, and what I got is 0.82 plus or minus 0.095. Okay, let me go and see if that is an option. If not, look at how you did your work. Maybe you made a mistake somewhere, but there is our answer, D. Okay. So that is the multiple choice questions. Most of the things do not involve a lot of calculations, just recalling things, particularly about your sampling method. So you definitely need to know all those sampling calculations. So now we calculations that we will have to show. So with a multiple choice, you don't need to show your calculations. You just pick A to D. Then question 2. We're told that suppose you would like to estimate the mean teacher's salary in Commerce region with 99% confidence to an accuracy within $2,000. You are told that the population standard deviation of teacher's salary in Commerce is known to be 6,000. Find the necessary sample size you need for this study. So here again, just need to recall the formula. So we know that N is equal to Z multiplied by sigma over our margin of error, and this is all squared. Now our Z over here, this is Z of 0.01 divided by 2, because we want an accuracy of, we want to be 99% confident. So our alpha is 0.01, but then we divide this by 2. Then sigma is the 6,000 that we are given. Now this one we read from the table, you get 2.575. And sigma, we're told, is 6,000. And our margin of error, this is 2,000. Okay, then you just substitute everything you know. So we have 2.575 times 6,000 divided by 2,000. Then you square this. So this on your calculator is 59.675625. And we always like to round our number up. So this is approximately 60 people that you need to include in your sample. So you can answer the question with a statement. Says find the necessary studies. Okay, so we need approximately 60 teachers in our sample. Okay. And then 2.2. Suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. The random sample of 36 scores is taken and gives a sample mean score of 68 points. Find a 90% confidence interval estimate for the population mean exam score. So here we are not told what the population standard deviation is. So that should tell us we're either going to use a Z or a T. If we knew what sigma was, then we would automatically use a Z, but we don't know what sigma is. So the next thing we have to ask ourselves is the sample size big? That means, is it 30 or more? Here we took a random sample of 36. This is greater than or equal to 30, so we're going to use a Z and not a T table. Okay, so we know that X bar is equal to 68. So we want a 90% confidence interval. Okay, so this is the information that we're given, that the standard deviation of the sample is 3. The population, the sample size is 36, and then we want to construct 90% confidence interval. So we know that our confidence interval will look like this: X bar plus or minus Z alpha over 2 multiplied by S over the square root of N. So it's important to write the formula down. There are usually marks given for writing down the formula, so please make sure you write it. So I have X bar is equal to that. So from here, I know that my Z of 0.1 over 2, this is Z of 0.05, and this we read from our table. This is 1.645. Okay, so we have everything we need in order to work this out. X bar, we say the 68 plus or minus Z alpha over 2. This is 1.645. Our S, this is 3. And then we divide it by the square root of 36. So this is 68 plus or minus 0.8225. Okay, so this gives us this interval over here, 1775 mu 8. Okay, and then as always, we can write a short sentence just answering the question. It says, we are 90% confident that the true mean or lies in the interval from 67.175 to 68.8225. Okay, so when I write a statement like this, there are a few things that I'm looking for. The first thing is, how confident are you? So you need to give me what that is. It's 90% confident, 95, 99, and confident of what? The true mean, the true proportion, the true something, and then you state the interval. So those are the three things that we mostly look for in your statement if you're asked to give a conclusion on your confidence interval like this one. And then 2.3. Suppose a baker claims that his bread height is more than 15 centimeters on the average. Several of his customers do not believe him. To persuade his customers that he is right, the baker decides to do a hypothesis test. He baked 10 loaves of bread. The mean height of the loaves of the sample loaves is 17. Is 17 centimeters. Then the owner knows from baking hundreds of loaves of bread that the standard deviation for the height is 0.5 centimeters. And the distribution of heights is normal, so it's normally distributed. Help the baker to do this hypothesis test at 1% level of significance. Okay, so here is the data summarized. X bar is 17 centimeters, and this 0.5 is sigma, because that is information from baking hundreds of loaves. So it's of his population, of all the bread that he has baked. He knows that the standard deviation is 0.5. So this is sigma and not S. Okay, so we need to do a hypothesis test. So what he is testing is whether the average is 15 or more. Okay, so that will go with our alternative hypothesis. So we have the null hypothesis and we have the alternative. So he is testing to check whether the mean is greater than 15. Because that is his claim, that is what he is saying. He says my bread is 15 centimeters or more high. And then the null hypothesis is just the opposite of the claim. So mu is less than or equal to 15. Then we need a test statistic. So remember, this is step 1. There are 5 steps that you need to follow in your hypothesis testing. First thing, your hypotheses, which we have done here. Step 2 is your test statistics. So we have Z stat, or the Z calculated. This is X bar minus mu over sigma over the square root of N. Okay. And here it's important that you know that this is sigma, because if it was S, then it would be a T statistic, because the sample is small. He's only baked loaves to check this hypothesis. Okay, so because we know sigma, I know this is a Z hypothesis test. Otherwise, it would be a T. So make sure when you're reading these questions, you understand those small little things. Okay, so we say mu minus x bar minus mu. So this is 17 minus 15 over sigma. This is 0.5 over the square root of 30 of 10. Okay, so this again, you just type in on your calculator, and I got 12.64911.064. This is approximately 12.6491. Okay, that is step number 2. Then step number 3, I need to have a decision rule. So to do that, I need my critical value or values. So this is a one-tailed test because my null hypothesis does not say not equal to. It just says greater than. So this is an upper-tailed test. So my critical value will be somewhere over there. So this is the Z critical value. Okay, now this area here is the rejection region, and it is equal to 0.01. So what we do on our table, we again look for 0.01, but we did it with one of the multiple choice questions, and we know that our critical value is 2.33. Okay, then our decision rule. Here I want to see it stated clearly. That will. Okay, I don't know what's happening. All right, it's stable now. Okay, so this is under what conditions will you reject or fail to reject H0, and those should be clear. So here we say that we will reject H0 if the Z stat, the Z calculated that we get is greater than 2.33. Okay, then step number 4, based on this rule that you have set. So step number 4, we say that since the Z stat that we calculated, this is 12.6491, this is greater than 2.33, we reject H0. Okay, that is step number 4. Step number 5 is your conclusion. What does it mean when you reject H0? So this means that we are 99% confident that the average height of the Baker's loaves is more than 15 centimeters. Okay, so that is your conclusion. So again, I would want to see, this is how confident we are. We're 99% confident. Confident of what? The average height of the bakers, of the loaves, and what about the loaves? That they are more than 15 centimeters. Okay, and make sure your conclusion you word it is in line with your decision over here. So don't reject H0 and then write this in such a way that when somebody reads it, it's not in line with rejecting H naught. So we are 99% confident that we fail to provide sufficient evidence that this, okay, so try and make it as simple as possible so that anybody who's reading it can understand that, okay, you've rejected H naught, that means the height is 15 centimeters or more. Okay. And then 2.4, with individual lines. I think this was the question in the assignment, or part of it anyway. With individual lines at various windows, a post office is interested in the standard deviation for normally distributed waiting times for customers on Friday. The post office experiments with single main waiting lines and find that for a random sample of 25 customers, the waiting times for customers has a variance of 12.25 minutes. Then 2.41, with a significance level of 5%, construct a confidence interval estimate for the variance waiting time of all customers at this post office on a Friday. Okay, so this is 2.4. Okay, so we know that alpha is 0.05. Now the formula for the confidence interval is this, n minus 1 s squared over sigma, chi alpha over 2, and then the degrees of freedom are just n minus 1, and sigma squared n minus 1 s squared okay, so that is what we know. That's the formula. Now from the question we are told that s squared, this is equal to 12.25. okay, and then these two, we just have to read them from our table. So the first one, alpha over 2, so that's 0.025, and then degrees of freedom, this is 25 minus 1, so that's 24. Okay, when we read this from our table, we get 39.36408, and then here we have 1 minus 0.025, which is 0.975, and still 24 degrees of freedom. And this is 12.40115. Okay, then you just substitute the values there and get the confidence interval. So we have 25 minus 1 s squared. This is 12.25 divided by 39.36408. 25 minus 1.25 divided by 12.40115. Okay, then on your calculator, 7.46873 997. Weird. 23.7074787, and then to 4 decimal places, 7.4687. 0.7075. Okay, so that is the 95% confidence interval. Then, as usual, write a statement just explaining this confidence interval. So we are 95% confident that the true variance waiting time of all customers at the post office on a Friday is between 7.46 and 23.707. That's it. Okay, so again, with your statement, what I want to see is how confident are you? Confident of what? The true variance. And then you give me the endpoints. It's between this and that. So I'm not going to write this one here, but you guys should write it. Then 2.4.2. Now this is the question that was in the assignment. Assuming that the estimated population variance at this post office is 51.84 minutes, is there evidence at 1% level of significance to conclude that a single main waiting line causes low variance among waiting times for customers? So I think almost everybody in the assignment that I could see got this right. So let us do it very quickly. So here we're doing a hypothesis test. So we have a greater than or use equal to, that's fine. And then the alternative, this is less than. Okay, so again, we want to test if it causes a lower variation, so that's why it is a lower tailed test. And then our test statistic, we have chi-squared statistic. This is n minus 1 squared over, that is given in the null hypothesis. This is 25 minus 1, then s squared from the question of the variance of the sample, that is 12.25. Then we divide by the 51 that we are given in our null hypothesis. 51.84. This is 5.671296. 296, and this is approximately 5.6713. Then step number 3, our decision rule. So what we will have is our chi-square is like this. Then this is a lower tail test because our null hypothesis has the less than or equal to. So this is our rejection region over here, and we want to work out this critical value. Okay, so this is just equal to this squared. Then we have 1 minus 0.01, and then we have 24 degrees of freedom. So this is chi-square, and 1 minus 0.01, that's 0.99, and then 24 degrees of freedom. This is equal to 10.85636. So that is our critical value. Then we state the decision rule. We need to say this is when I will reject the null hypothesis. So our is that we will reject H naught if the stat that we calculate is less than 10.85636. Then step number 4, now we make a decision. We compare the statistic that we got with the critical value. So we got 5.67 and it is less than this, so we will have to reject the null hypothesis. We say that since the calculated statistic, which is 5.6713, this is less than 10.85636. We reject H naught. And then the last step is your conclusion. What does it mean when you reject H naught? Say that we conclude at 1% level of significance. That a single main line causes lower variation among waiting times. For customers. Okay. Okay, so something like that. So again, here I will want to see the level of significance or the confidence level, and the statement that follows should be in line with you rejecting H naught. Then number 3, this is a chi-square test for association. So we have to see whether two variables are related. So here we have to test at 5% level of significance if there is enough evidence to conclude that gender influences ice cream flavor preference. So 3.1. Okay, so this is a hypothesis test. So we will do the usual 5 steps. So we have to do a hypothesis test with the 5 steps: your hypotheses, your test statistic, your critical value, your decision rule, then you make a decision, and then a conclusion. So the first thing is our H naught and our alternative. So here we're testing if there's a relationship between ice cream preference and gender. So your null hypothesis always says no, there is no relationship. So there is no relationship or association between gender and ice cream preference. And then the alternative always says yes, there is a relationship or an association between the two. there is our alternative. There is a relationship between gender and ice cream preference. Then that's step number 1. Step number 2, we find our test statistic. That means we have to work out that table. So we have the observed values, and then each observed value has its own expected value. Now the way we work out the expected value, if you remember, is we will sum up the values in the rows and in the columns. So this 100 and 300, I'll add them together. This will give me 400. And then in this row, I'll say 100, 120, and 60. That gives me 280. So the expected value of this 100 over here is the row total multiplied by the column total divided by the overall total, and the overall total should be this 870. Okay, so here are my observations. I have 100, I have 300, 120, 200, 60, and 90. So you work out the observed values, the expected rather. So I got 128.7356, then 271.2644, 102.9885, 217.0115, 48.27586, 101.7241. Okay, and then what we do is we say the observed minus the expected. You square this and then divide by the expected. So here I got 6.414204, 3.044029, 2.809934, 1.33528, 2.847291, and 1.351257. Then the sum of all these values over here, that will give us our test statistic, which is 17.80024. Okay, so our test statistic, which is the sum is this 17.80024. Okay, and then we need a decision rule. So the rule is that we will reject H naught if is greater than this chi-squared critical value. So our chi-squared critical value, this is 1 minus 0.05. Sorry, it's just 0.05. And then we multiply row minus 1, column minus 1. Now here we have 2 rows, male and female, and then we have the 3 columns for the different flavors of ice cream. So we'll say 2 minus 1 for the 2 rows, which is 1, and then 3 minus 1 is 2. So 1 times 2 is 2. So this is equal to chi-square 0.05, and we have 2 degrees of freedom. This value, again, you just read from your table. This is 5.99146. So that is step number 3. Here, maybe I should have written the rule after I got this value. That makes more sense. This is 5.99146. So that is our rule. We'll reject H naught if our calculated statistic is greater than 5.99146. This one, I got it from the table. So next step is we look at our statistic and we look at the critical. Here our statistic is greater than the critical value, so we will reject H naught. I say that since period that is equal to 17.80 and this is greater than 5.99146, we reject H naught. We reject H naught, and then what does it mean when you reject H naught? We can conclude at 5% level of significance that there is a relationship between gender and ice cream preference. Okay, so again, I will want to see the level of significance, and your statement over here should be in line with you rejecting H naught. Okay, 3.2, compute a 4-period centered moving average trend for the time series. Okay, so this one, if you remember, 4-period moving average, I will just take 4 data points at a time and work out their average. Now with a 4-period moving average, I will have to do this twice because when I work out the average of the first 4, it falls here between 2004 and 2005, but we always want our average to be at a specific time point. So it must be either for 2000, 2003, and so on. So it should not lie between there. Okay, let's look at how we would do that. So we have our years. We have 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010. Okay, I'll only be able to do those, and then you will do the rest. Then the yield. Here we had 24, 19, 36, 32, 26, 34, 26, and 26. Okay, so the 4-period moving average, we take 4 points at a time and work out the average. So for the first one, I will take these 4. I'll add them together and then divide by 4. So I get 28, and that 28 should go in the middle. So you should have 2 data points above and 2 data points below, and it goes over here. And like I said, this 28 over here doesn't belong to 2004, and it doesn't belong to 5. It's right between, and that's what we don't want. We always want our average to be in line with the time period that we have over there. But we continue in the same way. I move on to the next 4. So 19, 36, 32, 26. I add them together, and oh, sorry, that's not 28. This is 27.75. Okay, and then the next one, just take the 4, and then the average goes over here. It's between the 4 that you use to get the average. So this is 28.25. And then we have 32, 29.5, 28, 28.75, and then here I would have 29.75. So there are other values here from 2011 to 2013 that just do not fit here, but you would work them out in the same way. So you keep taking 4 data points at a time, and then you work out the average. So this is the 4 period moving average, but this one we say it is uncentered. So this is the 4 period moving average, and this is uncentered. And then the next one we calculate will be centered because it will be in line with a specific time period. The way we do it is the same, but we take 2 points now. So I say 27.75 plus 28.75, then divide by 2. This gives me 28. And then I do the same thing with these 2. This gives me 30.125. And then those 2, 28.75. And those 2, 28.375. 29.25, and we have 30.25. Okay, I hope I've written this correctly, but you can check if the way I wrote them is in fact correct. I think I skipped one. Okay, but the way we work it out is exactly the same. So first one, take the first 4, get an average, and it goes there between 2004 and 2005, and continue all the way down your table. Then we want averages that line up with the time period. So we take the average of the 2. So over here, this one and that one, this gives me 28, and you can see this 28 is in line with 2007. This 30.125 is in line with 2006, and now they all line up, which is what we want. So whenever you have a time period or a moving average, which is an even number, so it's 4, it's 6, or whatever it is, then you would have to do this twice, so that your final average over here lines up with a specific time period. So this one over here, Okay, this is also called the 4 period moving average, except this one is centered. So the first one is not centered, but the second one is centered. Okay, so that's it. Then the next question, we have to compute the straight line trend. Y is equal to a plus bx by the method of least squares. So again, method of least squares, regression method, it means the same thing. So if you're asked, says by using the method of regression, well, you will do it in this way. If it says method of least squares, you will again do it in this way. So it's just another way of stating the same thing. Okay, so we have to find A and B, and then we will always be told what to start our coding with. So sometimes it's 0, sometimes it's 1. Here we are told that it is 1. So the time period, this is going to be your X. So I'll have 1, 2, 3, 4, 5, 6, and so on till the end. And then this yield over here, this will be my Y. So you know how to fill in this table. So I don't want to rewrite it. So what you will need are the following: the sum of all the X's. And here I got 66. The sum of all the Y's, which is 323. Then the sum of the X squareds, this is 506. The sum of the product of the X and the Y's, this is 2014. Okay, so once I have all of those like that, I've written them down like that. So once I have those stated, I can just work out my A and my B. So remember, you should work out B first because you need it in the formula. You use it in the formula for A. So this is N, the sum of the product of X and Y, minus the sum of the X's multiplied by the sum of the Y's, divided by N, the sum of the squares of X, minus the sum of the X's squared. So substituting the values over here. Okay, I didn't substitute, I just worked it out. 0.690909090, and it continues in that manner. But in the test, I want to see you substituting all the values, and I have them all here. You just plug them in. Okay, and this you can also check on your calculator if the B that you got from working this out is the same as what you have here. And then A, this is the sum of the Y's minus B, the sum of the X's, divided by N. And when I worked it out, I got 25.218236. So again, I would like to see you substituting. So here you'll put 323 minus the B that you have over here, 66 divided by N. That, and I like to leave this to 4 decimal places, 25.2182. Okay, then you write down the equation where you have where you put in the values of A and B that you calculated. So we have Y is equal to A, this is 25.2182, plus B, this is 0.6909x. Then the last part of number 3 says estimate the yield of maize per hectare in 100 kg bags for the year 2017. So here we have 2013, then we count forward going to 2017, and 2017 will have a code of x is equal to 15. So say that for for 2017, x is equal to 15. So we just substitute x over here, which is 15. So we'll have y is equal to 25.2182 plus 0.609 multiplied by 15. We got 35.5817. And then you can say that you can write a statement answering this question. In 2017, we expect a yield of 35 point that, I don't know, what is it saying, per 100 per hectare, or yeah, you just word it to answer the question that is given. Okay, I think we can do one more. Okay, we're almost done with the exam. Nice. Okay, so question 4. Here we have to calculate some index numbers. But again, here, none of these are difficult, pretty simple to do. For A, this is question 4A. Okay, we have to calculate the simple aggregate quantity index. Okay, so remember, quantity, we're talking about if this is like groceries or household things. So when we're talking about quantities, we're talking about how much you were using. And then your conclusion should be something like the amount that we're using or buying has gone up or gone down by this much. That's all we want to see. So the aggregate just means add up all the quantities of everything that you were using. Now, a simple quantity index would be specifically maybe for bread. You want to see, has the amount of bread that you are buying gone up or gone down? But an aggregate means this is my grocery basket. Has the total amount of all my groceries gone up or has it gone down? So aggregate means everything add together. Simple would be maybe for bread or just for milk or just for salami. Okay, so for A, the aggregate is just the sum of all the quantities in the current year divided by the sum of the quantities in the base year. Multiply this by 100%. So it's how much you're using now divided by how much you were using in the base year multiplied by 100%. So here I add up all the quantities. So it's 25 plus 44 plus 380. Let me just see that. Okay, so here are the quantities: 25, 44, 380. So it's not the prices this time, it's the quantities. And then we divide by the quantities of the base year, how much we're using then. 18 plus 32 plus 300. Then you multiply by 100%. So you need to add all these together, all that together, divide, and then multiply by 100%. So just type it in correctly. If I did, what I got was 128.2857143, which is approximately 128.2857%. Okay, so it went up from 100% to 128%. That means the amount of food that the family consumes has increased by 28%. Let me just see the question. Okay, this is the typical expenses, the food expenses of a typical family. Okay, so I'll just use that in my wording. So the conclusion I wrote is that the amount of food that a family or a typical family consumes per month has increased by 28.29% from 2000 to 2004. Okay, so that's what I want to see. It has increased by how much, and then give me the time period. Then B, we have to work out last year's price index and then interpret your results, and then we do the same thing with the PASH index. So here, just make sure that your PASH and your last year's are saying the same thing. The values will not be identical, but they must be in line. So one should not say that is this the price index or the quantity index? So one should not say that it has gone up and the other one is saying it has gone down. Okay, so we have last year's price index. So the formula is just Q naught, P naught over Q naught. Sorry, that's P1 multiplied by 100%. So here, I'll just write down what I got. So this is 18, 110, 32, 130, plus 300, 81, over 18, 94, 32, 86, 300, 74, and then multiply by 100, and I got 114.24711%. So here we want to see you say something like it has increased by 14.25% from 2000 to 2004. And then the last one is the PASH quantity index. So make sure you read it correctly. I just realized now that in the notes I made, I calculated the price index, but this is the quantity index. So we have the formula for that. All you need to do is substitute in the formula, like I've done over here, multiply the values, and then your conclusion is that. Okay, so I'm glad we managed to finish that. That was a 3-hour paper, but we did it in like 90 minutes or less. All right, so I will stop here for now. The last one, you guys can work that out. I don't know if you guys have any questions, things to clarify. Are you ready for the test?